All right, so I'm just making this video for those of you who are not with us right now. So this way you kind of have something you can look at to help you understand what we're doing in class and to help you with your homework. And also for those of you who were in class, this could be something to help you if you weren't sure then as well. But it's not mandatory for anyone to watch. We're not going to pick back up on the videos until after we finish these next two parts. And the last part of this unit where we're actually going to learn how to graph lines, there will be a video that's required for that. But for the next two videos, it's just creating them for those of you who aren't here, to give you a chance to kind of see what we did in class and to kind of hear me talk about it instead of just reading it in the email. All right, but what we focused on in the last class is we first did like an exploration to kind of come up with a slope, and talk about lines and things that form lines and things that don't form straight lines. But for this, we're just going to jump straight into the nitty gritty. All right, so what we were focusing on is talking about slopes. And a slope is the rate of change between any 2 points on a line. So if we have a line here, it's telling us how quickly our line is changing. So you see we have these 2 points that I'm highlighting in red now, and our slope will be telling us how our line is changing, the rate of change between it. And specifically, it's measuring the steepness of a line. And when we talk about the steepness of a line, what we're actually solving for here, let me just move this over a little bit. What we're actually talking about there is the steepness of a line. So if I draw this line here, and then let me draw another one in red next to it. And if I ask you which line is more steep, well, the black line is more steep than the red line because it's increasing it higher, faster. So like if we are doing a hike and we approach a hill, and the hill, when we look in the horizon, it's like barely above us, that wouldn't be a very steep hike. But if we get to the bottom of the hill and it's straight up and down, that would be an extremely steep hike. So the steepness of a line is it's actually making a ratio of our vertical change to our horizontal change. So it's telling us how quickly we are changing vertically in comparison to our horizontal change. So we learned about ratios, and when we write ratios a specific way, so if I said compare apples to oranges, and I asked you to rewrite this in one of the different forms that we learned, we can either write it as apples colon oranges or apples over oranges. So since we are comparing steepness, it's our vertical change to our horizontal change. If you were to write this in as a fraction, it will be our vertical change over our horizontal change. Right, because when we are talking about the steepness of a line, we're comparing how quickly we're changing vertically to how much we're changing horizontally, because it's telling us how quickly our line or the mountain or the hill, how quickly it's increasing. All right, so that's why when we're talking about our slope, it is the ratio of our change in y, because our axis, when we have our coordinate plane, when we are moving up or down, that is our y value that's changing, because our y axis is the vertical axis. So when we're moving up and down, or a vertical change, it is our change in y. And then the symbol that you're going to see me write this is this delta y, and that represents the change in y. All right, so because the steepness is specifically vertical change to horizontal change, when we write this as a fraction, it needs to be our vertical change in our numerator. And since our y axis is our vertical axis, it's telling us how we're changing in our y value. And then it's over our horizontal change. And since our horizontal axis is our x-axis, and that's telling us how we're moving horizontally, that means that it is going to be in our denominator. And once again, change in x we can represent with that delta x. So you're going to see me write change in y or change in x like this, that's in green, and not in words. All right, but our slope is telling us how quickly we're changing in our y value compared to our x value. All right, and there's a couple ways that we can actually find our slope. And if you look over here, we can literally just identify the points. And when we're identifying the points, it's important that you're picking the ones that are in the corner of the box, because that's going to guarantee that they're whole numbers. So you see, when I look down on both of those points for x and y, they give me a whole number. If I were to pick any point on this line, let's just say this one here, well, if I try to then look and see what my x and y value is for there, I'm going to have to approximate it, because it's not at a whole number, it's in between those numbers. So when we're picking points to try and determine our slope, we want to make sure we're picking points where both our x and our y value are whole numbers. And maybe we can't for some whatever reason. If you get a problem that it can't, well, then you would just have to approximate it at that point. But if we can, we want to make sure that we're picking the points that are crossing through the corner, because then it's whole numbers. And all you do is you literally are just counting. So to go from this point to the other, I'm moving 2 units to the right. And when we move to the right on an x-axis, we know that we're moving in a positive direction. So my change in x in that case would be a positive 2. And then from there, to get to the next point, I'm moving up 1, 2, and 3. And as we move up on our y value, our values are increasing, so it's positive as well. So my change in y will be a positive 3. So then, since our slope is change in y over change in x, that would then be equal to 3 over 2, because that is how we are changing. All right, we're changing 3 vertically as we're moving 2 horizontally in a positive direction. And just so you know, we don't have to start with that bottom point. We could have started with this top one. And now I'm counting 1, 2 units to the left. Well, when I move to the left, my change is negative. So in that case, I'm going to, my change in x will be a negative 2. And then from there, I'm going down 1, 2, 3. So I move down 3 units. And when we move down on our y-axis, that's also negative. So our change in y would then be negative 3. So if we go to do our slope from that point, you'd see we're still going to get the same answer, because a negative 3 over negative 2, well, when we divide a negative by a negative, it turns a positive. So it still gives us a positive slope of 3 over 2. So the only thing you have to make sure you're doing, though, is being consistent from which point you are starting to count from both times. So meaning I can't start counting my horizontal change here and then go down from this point for my vertical change, because I'm not being consistent. So just make sure that you are being consistent in the point that you start with to the point that you finish with. All right, so our slope is simply telling us the steepness of our line, and it's telling us our change in y over change in x. If you've learned this before, some of you might have seen it as rise over run. I don't really like explaining it like that in class, especially with students who are ESL. I like to just say change in y over change in x. All right, so there's just 2 more examples for this, and then we'll be done with this video. All right, so for these, we're just going to go over finding our slope. Just so you know, there is a variable that represents our slope, and the variable that we can use to represent our slope is m. So we can say our m is equal to our change in y over change in x. So I'm going to show you 2 different ways that we can actually solve this. And next year, the second way I'm showing you with a formula, you'll have to be able to do. But for now, if you just count, by all means, go ahead and count. So what we're doing then, if we're trying to find a slope of this line, I'm going to start with this point because that's the one I feel like it. So I'm going to figure out my change. You can do either your change in y first or your change in x. It really doesn't matter. But I'm going to go ahead and just count horizontally first. So 1, 2, 3, 4, 5. So I moved 5 units to the right. And when I move along my x or horizontal number line to the right, I know it's going to be positive. So I'm going to say, okay, my change in x is equal to a positive 5. And then from there, I'm counting up 1, 2. So when I go up, I know that's also positive. So my change in y was equal to a positive 2. So now to figure out my slope, I just plug it into the formula, if you want to say that, change in y over change in x. So then my slope is equal to my change in y was 2, my change in x was 5. So then my slope for this line is equal to 2 over 5. All right, so we're not actually going to do this number 2. We're just going to do both of the problems, both of the ways for this number 1. So we already know our slope is a 2/5, 2 over 5. So one of the other ways that you can do this is you can actually use a formula. And our formula for our slope is equal to y2 minus y1 over top of x2 minus x1. So you see these numbers are written at the bottom of our variable and not at the top. So they're not exponents. I'm not saying we're squaring y. What these represent is, let's say that in class I was talking about multiple students might have cats. So let's say Ethan has cats, and let's say Marcus has cats. Well, if we're talking about their cats, we might want to use C as our variable. But when we're talking about the cats that Ethan has, maybe we want to put a little subscript here as an E to represent, well, these are Ethan's cats. And for Marcus, we will put a little M there and say, well, these are Marcus's cats. So that little subscript that's written at the bottom is allowing us to use the same variable over and over again, but then to be able to represent or denote the variables for multiple things. So when we see we have these 2 order pairs, we have an order pair of 0, 0, and we have an order pair of 5, 2. Well, both of these order pairs represent an x and a y, because our order pairs are written as x comma y. So if we're talking about multiple order pairs at once, we need to be able to represent them differently. And since they're all x and y's, we use the subscript. So instead of just writing x and y, we can represent it as x1 and y1 and x2 and y2. This represents an ordered pair of x and y, another ordered pair of x and y. But since these both have the subscript ones, it represents that these are the same ordered pair, that they're part of the ordered pair. Here, they have the 2, so it represents the second order pair that we have, but since they both have the subscript 2, that they're both part of the same order pair. You can't do x1 and y2 because these have different numbers or different subscripts, so they're representing two different order pairs. So when we're creating these subscripts are just allowing us to keep reusing the same variables, but then also to denote them in different ways. So when we see this formula of y2 minus y1 over x2 minus x1, that just means that we're using two different order pairs. And it doesn't matter which ones you represent as x1, y1, or x2, y2. I'm just going to go ahead and say that this 0, 0 is going to be our x1 and our y1 order pair, and this 5, 2 will be our x2 and our y2. The only thing that matters is that whichever order pair you denote as x1, the y needs to be y1. And whichever one you represent as x2, the y needs to be y2. Right? I could have made this x1, y1 if I wanted to. It really wouldn't matter. Right? But it's just whichever one I denote as my first order pair, they both need to have that subscript of 1, and so on with the second one. All right, so now, by me representing this, I'm saying x1 is equal to 0, because that is my x value for this order pair that I said was going to be my x1, and my y1 is also equal to 0, because that's my y value of this order pair. My x2 I'm saying is equal to 5, because that is my x value of that order pair, and my y2 I'm saying is equal to 2. So now that I know what all these are, I can just simply plug them into my formula. My slope is equal to y2, which I said is equal to 2. So 2 minus my y1, which here I'm saying is equal to 0, over top of 5 minus 0 for x2 minus x1. And now 2 minus 0 is equal to 2. 5 minus 0 is equal to 5. So here I'm saying my slope is equal to 2/5. So you see, no matter if I count or if I go ahead and use the formula, I still get the same answer either way. It is completely up to you how you do this for now. But next year, this is mandatory. You have to be able to use the formula. All right, that is it for this video.